Hey, good morning, everybody. This is Mr. Ainsworth again, and we're going to get into your Unit 5 homework here in AP Pre-Calc. So let's get started. Let's go for it. All right, the number of shoppers in a shopping mall, T hours after it opens, is given by S of T. Okay, so I already know what T stands for in terms of hours here. The number of store clerks needed to attend S shoppers is given by C of S. Okay, so C here is the number of store clerks needed here. And it's because it's given by C of S, where C stands, I guess, for clerks. So it's a clerk function, okay, for S shoppers in here. So what is this statement in the context of the problem? We want to interpret it, okay? So here we go. So C stands for the number of clerks needed, and in this case, it's the 11. So number of clerks, store clerks, that is. Okay, so number of store clerks needed. All right, in this case, guess what? It's 11. So is 11. But after how many hours? And so we have to look a little bit deeper here. And it says T hours after it opens. But in this case, right here, T is 3. So T equals 3, which means after 3 hours after it opens here, 11 store clerks will be needed. So the interpretation is as follows. So after 3 hours, okay, after opening, after 3 hours after opening, because it's a little redundant, but you know what I mean. After opening here, 11 store clerks are needed. All right, and that's it. Okay, number 2. New cookbook here. You just got gives all the oven temperatures in degrees in Celsius. Most people aren't familiar with Celsius, so you're going to have to convert in this problem here, because the new cookbook must have been written in Europe, because it's in degrees Celsius. But your oven uses degrees Fahrenheit. So in the States, we use Fahrenheit. In Europe, they use Celsius or centigrade. So you're going to have to do a little conversion here. Additionally, your oven runs hot, and you always have to decrease the prescribed temperature by 15 degrees. Okay, so obviously that is important here. So you're going to have to decrease the prescribed temperature by 15 degrees Fahrenheit, not Celsius. Write an expression using the composition of functions that we determine how you might have to preheat your oven when a recipe from your new school book calls for a temperature of T degrees Celsius. Okay, so remember, T degrees. We're just gonna. I don't know why they use T degrees Celsius. C usually in these functions here, C stands for Celsius, F stands for Fahrenheit. So I think the easiest way to approach this was we have to convert Celsius to Fahrenheit, and the second equation will do that for us here. And all we have to do is adjust it by 15 degrees. It says we have to decrease, which means subtract 15 degrees from whatever, the Fahrenheit temperature is when you're doing this. So F here, which stands for the degrees in Fahrenheit, is going to be equal to 9/5 times Celsius here, whatever it is in the cookbook. Because remember, it's in degrees Celsius, as stated here, your new cookbook in degrees Celsius. So you take that, multiply by 9/5, and add 32, but that will give you your temperature in Fahrenheit, but you got to modify it here. We have to subtract 15 degrees Fahrenheit from it. So let's do that. So minus 15 degrees Fahrenheit, that's this portion. And then adjust it. So the new temperature, F here in degrees Fahrenheit, is going to be 9/5 times C, and then 32 minus 15, well, guess what? That's 17. And we get 15 degrees, a function that looks like 9/5 C plus 17. Okie dokie. Next one here. So number 3. Let's just tackle these as quick as we can here. Because it's a video, right? And you can slow me down by pause, play, rewind, and all that good stuff. So just remember that. If I go too fast, just do what you always do with videos here. All right, so number 3, a table with selected values is given for the functions f and g. The domain of both functions is all real numbers. find f of g of 4, okay? Well, let's do this in a little two-step process here first. Let's start off with the inner function, which is g of 4. So inner function. Okay, so g of 4, what is that? Well, x is your input here. Let's call the input. What is the output? So we're going to go to your function g here, and you're going to find 4. And it says right here, g of 4 is negative 3. So looking at the table here, I know that when you input 4 into function g, the output is negative 3. So remember, x is your input. After you take 4, substitute it in g, you get negative 3, which is your output. Okay, then you got to take that, well, now we know what g of 4 is negative 3. Then you got to evaluate the second function, f. So f of g of 4 is the same thing as f of negative 3, because again, I just figured out g of 4 is negative 3 here. But what is f of negative 3? Well, now you go to function f, and you figure that out. So you look at the table, and you go, okay, you find x equals negative 3, your new input right here, and f of negative 3 is 3. Okay, so that should give us our result. So f of negative 3 equals 3, which is our output of the second function. So the output of g becomes the input of f in the second function here. I talked about that in class as well. That was part of our learning targets, okay? So our function composition right here should be equal to 3. All right, number 4. We got two functions, f and g. Let's find f of g of 2 first. There's two different ways to do this. Probably the most basic way is to evaluate the inner function first. Okay, so I'm going to do that. I'm going to start off with the inner function. I'm just making some notes right here. So my first step here is to evaluate g of 2. So I take negative 3 times 2 and add 7. That's negative 6 plus 7, or 1. So I start with the inner function, evaluate it at 2, and then evaluate the second function at 2. So that's finding f of 2. And that means I got to take 2 squared minus 1. That's 4 minus 1, or 3. Okay, so my composition is equal to 3. Why did I put 2 here? I'm going to, it's after school and I made a little mistake here. I don't know why I said f of 2. Oh, because I looked at the wrong spot. So I got to take this and I got to substitute 1 in the function f. So scratch that. All right, so I got to find f of 1. Sorry, I'm a little bit tired. My day started at 3:30 in the morning. I'm a little bit exhausted here. So you evaluate the inner function at 2. We get 1. Negative 6 plus 7 is 1. Then I take that and I substitute in the second function, f of 1. That becomes 1 squared minus 1, and that usually is 0. So my function composition is equal to 0. Okay, so that just pays, to, check your work. And then if you make a silly mistake like I just did, a visual mistake, just fix it, okay? No big deal. Write an expression for f of g of x. So what we need to do here on this one here is I need to substitute g into f, okay? Substitute g into f. I always start off with the inner function, which is g of x in this case, and substitute in the outer function. So I got to take all of g now, which is negative 3x plus 7, and substitute it in. So my composition, which is called f of g of x, is going to be equal to something squared minus 1. And what I need to do here is I just need to substitute the function g in here. Again, I'm substituting g, function g, which happens to be your negative 3x plus 7. Okay, and if you wanted to square that and simplify it, you can. I think we're good enough for that point right there. So that's called a composition. Composition of two functions, okay? F of g of x. Now, what they wanted, they reversed the order here. So here the orders are different. If you take a look at A and C, in A we found f of g of 2. Now we find g of f of 2. And we want to evaluate, are they the same or different? Is the composition, the way you compose functions, does it matter? Is it commutative, basically? And so here we go. Let's figure it out. So let's find f of 2 first. So I got to take 2 squared minus 1, which is obviously 4 minus 1, or 3. So I know f of 2 is 3. And now I compose them. I evaluate g at that number. So now I evaluate 3, or g at 3, and that's going to be negative 3 times 3 plus 7, which is negative 9 plus 7, or negative 2. So that tells me that my composition here, g of f of 2, all right, is equal to negative 2. So if you compare these right here, the first composition, f of g of 2 in part A, you get 0. You switch the order, g of f of 2, we get negative 2. And so here you have to understand that when switching the order of the functions in the composition here, that changes the results. So it's not commutative, okay? Order matters in compositions, okay? Order matters in compositions because it's not commutative. Because it is not commutative. It is not commutative. Commutative. Okay, so now they ask us, what is g of f of x? So now I've got to switch the order. I've got to substitute f into g. So now I've got to take all of f and substitute it into g. So let's do that. Okay, so I'm going to take, I got to take negative 3 times all the other function and then add 7. So I've got to substitute my function f inside there. So let's do that. F is x squared minus 1. And then, you can simplify it if you like. I usually have my students simplify it. So negative 3x squared plus 3 plus 7. And then if you add like terms, you get negative 3x squared plus 10 simplified. So there's your composition. And then that's it. Okay, so that's number 4. Number 5, if you're given a h of f of x, which is called a composition here, find a possible expression for the two functions a sub x. So one possibility, okay, first possibility here, let me see, h of x could be a rational function like 3 divided by x. And the other function that I can compose with it is the denominator over there, x squared minus 7. So if I compose, and if I take f, which is x squared minus 7, and I substitute it in here, you get that composition up there. That's one possibility. Second possibility, you could change it up a little bit here. The second composition possibility could be just 3 divided by x minus 7, and the other function, instead of x squared minus 7, all I have to do is just substitute x squared in, and then I'll get the same composition. So there's different ways of doing things here, guys. Those are two different possibilities, okay? So I'm going to put the word or here. It says find the possible expression. So there's two different ways for these possible functions, and you'll get the same composition, okay? Same thing. Okay, number 6. Here we go. Ooh, check this one out. Okay, so on this one here, given the functions here, f of x equals negative root x and g of x equals x minus 2, which of the graphs could represent g of f of x? Well, I would say that we should compose them and see what this baby looks like. Okay, that's what I would do. So I need to substitute f into g. So I need to take this f and I need to substitute it in. So I'm going to take the negative root x, substitute it in, subtract 2. And then I want to compare with the parent function. Compare with the parent function. I'm taking concepts from the last unit here. Which is your square root function, y is equal to the square root of x. So I'm going to graph that over here. So when x is 0, y is 0. When x is 1, square root of 1 is 1. When x is 4, square root of 4 is 2. So here's root x function right here. So I graph that. So I graph the parent function, then I'm saying, okay, how do these two functions compare? So then I say, okay, this negative right here that you see, that's a reflection over the x-axis. So reflect over x-axis. And all of this stuff should be known to you because we talked about this in the last prior unit. And then this -2, that's a shift down 2. So if I reflect root x across the x-axis, let me pick a different color here. I would reflect here, 1, 1 goes 1, -1, 4, 2 gets reflected 4, -2. And so this right here, this is negative root x. And then all I have to do is shift it down. So this composition here, negative root x minus 2, is actually part A. All right, so this one works. The other ones are not shifted properly. Like this here, part B, this one's shifted to the right. This one's shifted right. Not good. Okay, and this one was in part C. This was not reflected. So not reflected, not good. And then this was shifted up. This is not correct either. So this was shifted up, not good either. So the only one that was good is part A. And again, we're using a lot of prior learning here, guys. All this information that I just went over was from from the previous unit that we studied. So it really pays off to know your stuff well because you're going to use it later on. Okay, now number 7's quite interesting here, so let's go through it together. All right, so your favorite store sends out coupons in the mail. Ooh, first coupon is for $5 off your next purchase. So that's obviously important. I always highlight what I know and what's important. Coupon 2 is a 20% off coupon, which is, you're going to find out that that's worth more than a $5 off coupon. That's a nice coupon. All right, and it's applied to your total purchase. Let X represent your total cost. So now we know what X represents, total cost. Okay, of your purchase. All right, write a function to represent the cost of your purchase with only coupon 1. Okay, so we have coupon 2 is second. Let's talk about coupon 1. Only coupon 1. Now, coupon 1 is your $5 off. Okay, so here we go. So our cost function, f of x represents your cost. Just read the problem there. And so what we do is we just take off the $5 off your purchase. So we got to take your total cost x and subtract 5. Very simple. Now g of x is a different function because it represents using coupon 2. Now, whenever you deal with a percentage off, you got to multiply, not add or subtract. So if you're 20% off, okay, if you're 20% off, that means 80% remains, okay? You still have to pay 80%. Obviously, 100 minus 20 equals 80, okay? That's where I came up with that number. So you got to pay 80% of the total cost, and 80% is a decimal. Guess what? That's 0.8, or 0.80 if you want. Okay, so what I need to do is take 80%, okay, of my total cost. Or if you want to write it just 0.8x, that's fine too. All right, now it asks us to find some compositions. So I would say, let's see here. I would say compose them first, then evaluate. Yeah, let's do that. Let's compose first, then evaluate. So I'm going to evaluate or compose first. So f of g of x first. And then I'm going to get their composition first, then I'm going to evaluate. So I need to take g into f. So I need to substitute in g into f. Okay, let's do that. So I got to take 0.8x. All right, substitute in function f, subtract 5. Here's my composition. And now evaluate. So f of g of 75. So I got to take 0.8 times 75 and subtract 5. So what is that? Well, okay, if you just use your TI-84 if you want, okay, 0.8 times 75, that's 60, minus 5 more, that's $55. Okay, that's the cost Well, it says interpret. Oh, explain what it means in context. Okay, so what is this? What are we doing here? Okay, so what we did was we applied function g first. We took 80% of it first. We applied coupon 2 first. So right here, we applied coupon 2 first. All right, which is 20% off. That's why we multiplied it by 0.8, because remember, 0.8 remains. And then, okay, then we subtracted 5. Then we apply coupon number 2. So, or excuse me, coupon number 1. So then apply coupon 1, okay, which is $5 off. And that's why you see a -5 there. So if you apply coupon 2 first and then subtract 5, or coupon 2 first and then coupon 1, the total cost is going to be $55. Okay, what happens when you switch the order and you take $5 off first, then apply the 20% off? Ooh, all right, so now we switch the order here. So again, I'm going to start off with my function composition here. Now I'm going to substitute f into g. So going back up to the top here, look up here in green, so f into g, I need to take this and substitute it in. So on this one here, I'm going to take 0.8 and substitute in f here, which is x minus 5. So now going with the order of operations here, I need to subtract 5 from the total first, which means we're applying coupon 1, and then we'll take 80% of it, which is applying coupon number 2. Okay, so here we go. So now we evaluate. So g of f of 75 looks like 80% times 75 minus 5. So we apply coupon 1 first, and you get 0.8 times 70, which happens to be $56. 8 times 7 is 56, guys. So 0.8 times 70 is 56. Okay, which is a little bit more expensive. It's $1 more expensive. So here we apply coupon 1 first. So this is the exact opposite. Apply coupon 1 first, which is $5 off. Okay, then apply coupon 2, okay, which is 20% off. And you'll notice if you take $5 off first and then 25% after that, you end up paying $56, which is $1 higher. So it's cheaper to apply the percentage first and then take off the flat amount of $5. So it says, in which order would you like to apply the coupon for your order? Okay, and so if you just compare the two, right here, if you compare these two, this is the cheaper one, this is the better way. All right, apply coupon 2 first. So take 20% off first. All right, and then apply coupon number 1. Okay, it's cheaper. Now, some of you guys are saying, oh, it's only $1 cheaper. Well, I don't know about you guys, but for every dollar saved is one more dollar in my pocket. So be smart about it. Use your mathematics and use your percentage off coupon first versus a flat. Okay, number 8. Ta-dun. Let's do it. Okay, so we got f of x is a root function, g of x is a rational function. Which of the following is defined as a real number? Ooh, real, okay, not imaginary. Okay, so let's go for it here. So g of 3, let's evaluate this first. Let's find out g of 3 first. So it's 4 divided by 2 times 3 minus 6. That gives you 4 divided by 0, which is undefined. Okay, so no good. Okay, it can't be A because g of 3 is undefined. Okay, how about f of 11 here? So again, I need to start with the inside function first. So f of 11. So I need to take the square root of 11 minus 2, which is square root of 9, which is 3. And then I got to evaluate g of 3, which we just found to be undefined. So it's not this one. It says which one's a real number. Okay, well, so far we've got two undefined situations. So now we take f of 2, see what's going on there. So f of 2 is the square root of 2 minus 2, which is 0. And then you have to find g of 0, which is 4 divided by 2 times 0 minus 6, which is 4 divided by negative 6, or negative 2/3. This one's good. So it looks like it's C here. This one's defined. Got a real number. Okay, that's a good thing. But why is D not a real number? So let's investigate it. So let's find g of 5. Now g of 5 is 4 divided by 2 times 5 minus 6. That's 4 divided by 10 minus 6 is 4, which is 1. And then you evaluate the outside function at 1. Okay, remember, you start on the inside, and then you work on the outside. Okay, and f of 1 is the same thing as the square root of 1 minus 2, which is square root of negative 1, which is an imaginary unit. So this is imaginary, and by saying that, it's not real. Okay, and that's why C is the only one. Okay? Okay. Last one. Number 9. Okie dokie. Artichoke, as they say. The graph of f is shown on the interval from negative 7 to 5. This is called the domain. So notice that this function starts at negative 7, goes all the way over here to 5. That's the domain of the function. Starts at negative 7, and then obviously goes to 5. And then they give you this function g of x. Okay, they give that to you. So g of x is 5x plus 8, some linear function. And they say find f of g of negative 1. So we start off with g of negative 1. Always start with the inside function, okay? Always start with inside function. Okay, so g of negative 1. So let's evaluate that. So 5 times negative 1 plus 8. That's negative 5 plus 8, or 3. And then you evaluate the second function, which is the outside function, at 3. So I'm going to switch to red here. We go on the graph, and we find 3 on the x-axis, go up to the function, and then read the y value. And there we go. F of 3, all right, is equal to 2. All right, so because of that, I can say my composition right here, f of g of negative 1, is equal to 2. Okay, now let's switch the order and evaluate again. So now, again, you start off with the inside function, f of negative 3. So then you go to your graph, because function f is on the graph, and you find negative 3, and you go to the graph. Wherever it hits the graph, you read the y-axis, the number on the y-axis, and this is f of negative 3, which is negative 4. Okay, so we know what the f of negative 3 is. It's negative 4, and now I evaluate the outside function at that value. So what's g of negative 4? Well, we know it's 5 times whatever the input value is, plus 8. So it's negative 20 plus 8, which gives me negative 12. So I can say that my composition, g of f of negative 3, is equal to negative 12. All right, there we go. That's a good experience of composition of functions, guys. That's why it's so important to do your homework, because, you know, you didn't do all of this in the lesson. You did part of it, but not anywhere close to all of this. Okay, so one more time, you need to do your homework well, and you need to understand it thoroughly in order for you to pull off anything on the exam. Okay, so just keep that in mind. Spend time doing your homework. We assign it for a reason. All right, and this is Ainsworth. I'll see you in my next homework video later. Take care, work hard, make yourself proud. I'll see you later.